We're continuing this review with problem number 17. This definitely involves some algebra. Maybe the easiest way to explain this, instead of sine of theta, what if I just had the variable x, which is more common for algebra? How would I need to factor this, and in order to solve it, the way I do it is with a trinomial, I do a product sum. My product is going to be -2, and my sum is -1. My product is 2 times -1. My sum is -1. Now I say, what can I multiply together? It equals -2. When I add them, equals -1. Well, obviously, 2 and 1. So those are my factors. So then the way I do this, so my factors minus 2x and plus x, and then you do factor by grouping. So this is like algebra. If you're not quite following this, I don't have time to really go into detail. So this factored is this. So that's what I'm going to do here, except instead of x's, I have sine of theta. So I did that just to try and make a little clearer of what was going on. So once again, take each of these parentheses and solve it. So that equal to 0. Sine of theta would equal 1. So for this case, solutions for this one between 0 and 2 pi, sine of theta is 1 at pi over 2. Then I have the other parentheses that equal to 0. You get sine of theta by itself, you get -1/2. The sine of theta is -1/2 at 7 pi over 6 and 11 pi over 6. So those are your three solutions. 18, last thing about 18, you'll see as I write it here, it's almost like they've already factored it, which is nice. So if I'm going to solve this, I'll just take each parenthesis, set it equal to 0. So solution, where is the tangent of theta equal to 1? Occurs two places, pi over 4 and 5 pi over 4. And then secant theta minus 1 equals 0. Secant theta equals 1, although because we don't like to work with secant, I'll change secant to, well, the cosine. And I take the reciprocal of 1 is still 1. So basically it's just cosine of theta equals 1. And that happens at 0. We don't include 2 pi because we're looking for solutions less than 2 pi. So it should be these three solutions. So now, number 19 is sine squared theta minus cosine squared theta equals 1 plus cosine theta. And the one issue here is it's going to be hard to sort of solve this with both sines and cosines. So I'm going to replace sine of theta, sine squared of theta, with 1 minus cosine squared of theta. Then cosine squared of theta equals 1 plus cosine of theta. And then I'm going to get everything on the right-hand side. So if I do that, I have 2 cosine squared theta plus cosine theta. The ones actually cancel out. So I can factor out a cosine of theta. 2 cosine of theta plus 1. So now to solve it, same thing as we've been doing, cosine of theta 0. Solutions for that would be pi over 2 and 3 pi over 2. And then 2 cosine theta plus 1 equals 0. Cosine theta is negative 1/2. Cosine theta is negative 1/2 at 2 pi over 3 and 4 pi over 3. So check solutions, pi over 2, 3 pi over 2, 2 pi over 3. Yep. So 20 cosine squared theta minus sine squared theta. Now in this case, once again, I don't want cosines and sines both. So now I'm going to replace cosine squared with 1 minus sine squared of theta. So now I have negative 2 sine squared theta plus sine theta plus 1 equals 0. I'm going to have to try to factor this again, although I don't really want, I don't like this negative here, so I'm going to multiply this whole thing by negative 1. Now, actually, we just did this a few minutes ago. Look at problem 17. 2 sine squared theta minus sine theta minus 1. We have the same thing here. So from this point on, I can follow 17. This is my solution. And same solution. So I don't really need to do this again. I already did it. I'm glad I remembered that. 21. Tan theta equals 2 sine theta. Once again, I don't want 2 different trig functions in here. Let's get everything on one side. And what I'll try and do is I'm going to substitute tan theta with sine over cosine, see if that helps us. No, I still have 2 trig functions, but because I can factor out the sine of theta, we might still be able to solve this. Because you factor out sine of theta, you can 1 over cosine theta minus 2. So I can actually solve this because I first say, well, sine of theta is 0. That occurs at 0 and pi. And then inside the parenthesis, 1 over cosine theta minus 2 equals 0. If I add 2 to both sides, 1 over cosine theta equals 2. If I do a little more algebra, basically I get cosine theta equals 1/2. I know that occurs at pi over 3 and 5 pi over 3. So those should be my solutions. I'm going to check. Yep. So you do enough of these, you'll get the hang of how to approach these. Tan theta minus cotangent theta. Now, this one, let me try and change cotangent to 1 over tangent. Now, just to get rid of this fraction, how about I multiply? This is algebra stuff. Multiply both sides by tangent of theta. You get tangent squared theta minus 1 equals 0. If I factor that, tan theta plus 1, this difference of squares, tan theta minus 1. So now I've got two equations. Well, for this one, end up with tan theta equals -1. And for the second one, tan theta equals 1. So your solutions from this first one, what angles is the tan -1? It's in 2 and 4. So it's 3 pi over 4, 7 pi over 4. And where is the tangent? Theta equal to 1, pi over 4, and 5 pi over 4. So basically, it looks like the solution should be all the angles with the denominator being 4. And then 23. Three times 1 minus, cosine of theta equals sine squared of theta. I think what I'll probably do is replace sine squared of theta with 1 minus cosine squared of theta. Probably multiply out these parentheses, get everything on the left-hand side. So I have 3 minus 3 cosine theta, 1 minus cosine squared theta. So let's get everything on the left-hand side. Cosine squared theta minus 3 cosine theta make sure this is correct. If I subtract 1, and I think this factors into, the factors are -1 and -2. So I think we have cosine theta minus 1. So from the first parenthesis, cosine theta equals 1. That happens at 0. Once again, we can't put 2 pi. From the second parenthesis, cosine theta equals 2. You know what? It's impossible. There's no angle where the cosine is 2. cosine. So from that second one, there's no solution. So it looks like there may just be one solution. All right, so that's all of those. Start with 24. Now we got a bunch of inverse trig functions. And once again, the key to inverse trig functions is inverse sine and tangent. The answers have to be between negative pi over 2 and pi over 2. And for inverse cosine, the angles have to be between 0 and pi. So once again, not really going to take the time to teach that now. That's just a quick reminder of what we have going on. So hopefully these go pretty fast. So 24. Inverse sine. Whenever I have an inverse sine, I always tell myself this is going to be an angle. So basically you say, for what angle is the sine 0? The angle is 0. (25) inverse cosine of square root over 2. Try yourself, what's the angle where the cosine is square root over 2? Now, once again, we're only looking in the top half of the unit circle. That's the only place we're allowed to look. So in that case, right, it's pi over 6. 26. Inverse tangent of negative 1. So what's the angle where the tangent is negative 1? And it has to be the first and fourth quadrant. So for this one, I know it's negative 1 right here. Now, normally we call this 7 pi over 4, but because of inverse trig functions, they call it negative pi over 4, because inverse trig functions go from negative pi over 2 to pi over 2. So 26 should be negative pi over 4. 27, the inverse sine, negative 1/2. So once again, let's go find an angle where the sine is negative 1/2. It's going to be right here. And in the inverse sine world, we call that negative pi over 6. When we get to 28, we start doing these sort of composite type functions. The sine of the inverse sine of 1/2, or the cosine, the inverse cosine, or all kinds of stuff. So most of these, you just figure out. The rule is you work from the inside out. So let's do some of these and you'll hopefully see what I mean. The sine of the inverse sine of 1/2. Inside out means, let's see if we can figure out what the inverse sine of 1/2 is. Once again, since it's an inverse trig function, I always tell myself this is going to equal an angle. So what's the angle where the sine is 1/2? Within where I can look, I can only inverse sines, the angles have to be the right half of the unit circle. So where is it 1/2? At pi over 6. So therefore, this becomes the sine of pi over 6. And the sine of pi over 6 is going to be 1/2. So as it turns out, sometimes when you do these, the sine and the inverse sine act as like inverse functions. They sort of cancel each other out. So you see they cancel each other out and you're left with 1/2. But you can't always assume that. So the safest thing is just to work it out and then see what happens. It's almost like a shortcut, but you have to know all the rules for the shortcut. So sometimes it's easiest, safest just to work it out. So 29 says the cosine inverse cosine square root 3/2. So working from the inside out, this is an angle. So for what angle is the cosine square root 3/2? It's actually pi/6. So I can say cosine pi/6. Then once again, the shortcut for this one would work. But there are some where the shortcut doesn't work, so. 30, the sine of the inverse sine of 2 pi. The sine of the inverse sine of 2 pi, inverse sine of 2 pi says, what's the angle where the sine equals 2 pi? And this is undefined. And with inverse trig, inverse sine functions, you cannot have an angle where the sine is 2 pi. For the inverse sine functions, they're only between pi/2 and negative pi/2. So since this is undefined, it's almost like there are no solutions. If someone just said these things cancel out, take the shortcut, they would have put the answer at 2 pi, which is incorrect. That's why you got to be careful if you try and use the shortcut. 31, the inverse sine, the sine of pi/4. Now we should have flipped them. The sine, the trig function is inside and the outside is the inverse trig function, but you still work from the inside out. So what's the sine of pi/4? Well, it's square root of 2/2. So you have the inverse sine. So I say, what's the angle where the sine equals square root of 2/2? Well, it's pi/4. So here the shortcut would have worked. (32), the inverse sine, the sine of 3 pi/4. Working from inside out, what's the sine of 3 pi/4? Square root of 2/2. What's the inverse sine of square root of 2/2? Now the answer has to come in the first or fourth quadrant. This is the first quadrant. Should be 3. Oh, no, 3 pi/4. Wait a second. Sine of 3 pi/4 is actually inverse sine of square root of 2/2, which is, what's inverse sine of square root of 2/2? It's actually pi/4, because inverse sine, the angle has to be in here. So that's a case where if someone tried to use a shortcut and said this equals 3 pi/4, it's not correct. equals pi over 4. 33, inverse cosine of the cosine inside out, cosine of 2 pi over 3 is negative 1/2. Inverse cosine negative 1/2. What angle is the cosine negative 1/2? It is 2 pi over 3. So the shortcut would have worked for that one. 34. Inverse cosine of the cosine of 2 pi. What's the cosine of 2 pi? It's going to be 1. Inverse cosine of 1. So what's the angle where the cosine is 1? Well, you have to choose 0 because 0 is what's allowed. And 35, inverse sine cosine of pi over 6. Cosine of pi over 6 is square root of 3 over 2. What's the inverse sine of square root of 3 over 2? What's the angle where the sine is square root of 3 over 2? Pi over 3. Looks like I have 4 more of these. Let me try and finish them. And maybe we'll take a break. So 36. The inverse cosine of the sine of negative 9 pi over 4. First question is negative 9 pi over, okay. Where is 9 pi over 4? 2 pi is negative 8 pi over 4, so it's really going to be negative 9 pi over 4 is right here. So that's going to be negative square root of 2 over 2. So now the inverse cosine negative square root of 2 over 2. So looking at the top half of the circle, where is the cosine? Negative square root of 2 over 2, it's going to be right here. So 36 should be 3 pi over 4. 37. The sine of the inverse cosine 4/5. All right, this was a little different because this is an angle. We would say the cosine of what angles equals 4/5. That's not a special angle. So it's a little tricky. So what you have to do is inverse cosine negative 4/5. Another way of saying that is the cosine of what angle equals 4/5. Based upon that, because if I call this angle theta, then this really becomes the sine of theta equals what? But I got to figure out information about what angle theta is. So I'm going to build a right triangle. So ca adjacent over hypotenuse. Pythagorean formula says that side's 3. Now, if this is my angle theta, and I know it's in quadrant 1 because inverse cosine is positive, which I know has to be in quadrant 1. So the sine, opposite over hypotenuse, opposite over hypotenuse. I believe 3/5 should be the answer. .38 says the sine of the inverse tangent of 7/4. Could do the same thing where if I call this inverse tangent of 7/4 theta, and I really have sine of theta, I've got to go figure out about theta. I could say tangent of theta equals 7/4. TOA, opposite over adjacent. Hypotenuse becomes 49 minus 16. Square root of 33. So the sine of theta opposite over hypotenuse. And this is all in quadrant 1. So the sine should be positive. Oh, except I made a mistake. You don't subtract these. You add them. Sorry. So it should be square root of 65. Okay, one more of these, 39. Cosine the inverse sine 7/9. So an angle. Basically, it's saying the sine of theta equals 7/9. Nine squared, 81 minus 49. Square root of 32, which is 16 times 2, 4 square root of 2. So cosine of theta, so ca adjacent 4 square root of 2/9. All right, so that completes them. So I'm going to stop now and continue in a minute.